Dear students, now today we are going to discuss about the properties of series. In the last term, we have already discussed about sequence and series, and now today, first of all, we are going to discuss about the properties of series. The first property you can remember as the convergence or divergence of an infinite series remains unaffected by the addition or removal of a finite number of its terms. Okay, so if the series is already the infinite series, so remain it will be infinite if you are adding few number of terms, or if you are deleting few number of terms, the series is already unaffected. Okay, if a series in which all the terms are positive is convergent, the series remains convergent even when some or all of its terms are negative. Okay, so if the series is positive, then remain series will be always positive. Okay, third condition is the convergence or divergence of an infinite series remains unaffected multiplying each by a finite number. If you multiply by a finite number, then in that situation also the nature of the series will not change. Now, for example, let us consider this is an infinite series. This series is infinite series in which all the terms after some particular terms are positive. It is a positive term series. An infinite series in which all the terms after some particular terms are positive, it is called positive term series. Like for example, if you write minus 9 minus 7 minus 5 plus 5 plus 7 plus 19, then ultimately the total sum is positive. It means this is a positive term series as all its terms after the third are positive. Okay, the series of positive terms either converges or diverges to plus infinity for the sum of its first n terms, omitting the negative terms tends to either finite limit or infinity. Okay, so this is the important properties of the series of positive terms. Okay, now what is the necessary condition for convergence? So this is the necessary condition for the convergence. If a positive term series summation of un where n tends to infinite is convergent, then limit n tends to infinity un is 0, and it means the important part is this: it is important to note that the converse of this result is not true. So this is very important, and I want from the student you have to establish this result. The converse of this theorem is not true. Converse of this result is not true. Second condition is if limit n tends to infinity un is not 0, then the series summation of un must be divergent. If this is not 0, then the series must be divergent. So this is important conclusion, and we oftenly call it necessary condition for convergence. Now, test for comparison. This is very important test, and we have to remember that is known as P series test. P series in a series of the form summation of n is equal to 1 to infinity 1 by n power p, and 1 by n power p, which is called the P test also, 1 by 1 plus 1 by 2 power p plus 1 by 3 power p. So we have to take the inference from here. The convergence of P series means converges for every value which is greater than 1, and diverges for if p is less than or equal to 1. So this is about the test for comparison. And what is the P test? P series, the summation of 1 power np. This is very helpful series for the comparison test. So we have to remember these are the few example. If you look any book, then you will find certain example. All the example here I have collected. So you can test the convergence, the nature of convergence, by applying the comparison test of all the examples. So which is shown here. So for that purpose you test it. Now moving further, here if two positive term series summation of un and summation of vn be such that summation of vn is converges, then un is less than or equal to Vn for every value of n, then summation of Un also converges. Okay, so you look if this is in the broader perspective. In the comparison test, the idea is to compare a given series with a series that is known to be convergent or divergent. So because of that, this is called the comparison test, because two positive term series, summation of Un and summation of En be they will converge or diverge together. So here it will be very easy for you. Just take it in a set and superset panel. So Vn, you can look, Un is already contained in Vn. Okay, the Un is contained in Vn, it means Vn is a superset and Un is a subset. Okay, so in that sense you can keep your picture ki why we are saying ki both are converge or diverge together. Okay, so now this is if two positive term, similarly we can say if two positive term series summation of Un and summation of Vn be such that if summation of Vn diverges, then Un is greater than or equal to Vn, Un is greater than or equal to Vn, and in that sense for all values of n, then summation of Un also diverges. Okay, so here this here in this graph, only you can say ki this is your Un. Don't say this is Vn. This is Un. Actually, this is Un and this is Vn. Okay, so this is Vn and that is Un. So this is Vn. You can say this is Vn and this is Un. Okay, so now in this way it is clear how you can discuss. Now the most important part is limit form. The limit form is most important form. Okay, if two positive term series summation of Un and summation of Vn be such that ki limit, you have to remember this, limit n tends to infinity, Un divided by Vn is finite quantity, that should not be zero. Then you can say ki the series summation of Un and summation of Vn converges or diverges together. If Un will be converged, then Vn will be converged. If Un will be diverged, then Vn will be diverged. So this will be converged or diverged together. So this is the limit form of the series. Now, for example, just to look one example, to test the convergence of the series limit n tends to infinity under root n divided by n square plus 1. So this is very easy for you, and very easily you can already you can prove this. Un, first of all, you can write under root n divided by n square plus 1. Then here you can see ki this is n power 3 by 2. You can take this n square from here, the n square 1 plus 1 by n square, and under root n is here. Then after cancellation of the n power half, you will get here n power 3 by 2. So Vn is 1 by n power 3 by 2. Now limit n tends to infinity, Un by Vn is limit n tends to infinity, 1 by 1 plus 1 by n square. On simplification you will get, and that is 1. That is a finite and non-zero value. It means summation of Vn is 1 summation of 1 by n by 3 by 2. That is convergent series. If since here you compare with the p series, to summation of 1 by n power p, here the value of p is 3 by 2 is greater than 1. Hence by comparison test you can say ki summation of Un is also convergent. In this way you have established this and this is about the comparison test. Thank you very much.